Right, welcome back once again. Greetings. I hope you have gone through the introductory videos, introduction to trigonometry. We have investigated and discovered the sine ratio, the cosine ratio, and the tangent ratio. They are all ratios. We know that. And just to give you a little hint, we summarize those three ratios using this acronym SOCA-12. Some people say silly old hens cackle and heckle till old age. There are just different and nice classical sounds that have been made around this. But the bottom line that you should know is that the sine of an angle in a right angle triangle is the opposite over hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So I've got a right angle triangle here for you. And I just want to talk about notation. It's important that we get the notation right. In mathematics, we are particular about how we write things because mathematics is a language, just as it is with your language subjects where spelling and grammar are an issue. We do the same thing here. We're going to make it a big deal on how you write things in mathematics. So here's a triangle with 3 points, point A, point B, and point C. Okay, that's what the tri in trigonometry refers to, just refers to 3. And then trigonometry, that is what? Angles and measuring angles in triangles. Okay, that's where trig is from, and that is why I took you through that similar triangle investigation. So if I've got this, we have a convention that we use in maths. The side which is opposite to point A in this case, take note that is point A, will often be written as small letter a, and the side which is opposite now to what? To B or angle B will often be written as small letter b. And I'm sure now you have done the math that the side opposite to point C or angle C, if you like, will be written with the letter small c. I want you to also be aware of the fact that A is a point, but A with a head is an angle. So this here is a point. If you write this, you're just talking about a point. But if you write that, you are talking about an angle. So that is how we differentiate. We often catch students writing this, but actually intending to write that. So I need you to be very much aware of this because these are costly in the exam. You lose marks, a mark or so, simply because of notation. So please be aware, if you want to use 3 letters to refer to an angle, let's say we want to refer to that angle, we will say angle ABC like that, a head where, a head above the letter where the angle is formed. Another notation that they use is to use the symbol angle in front there, and you write ABC like that. And of course, now once you use this notation, you need to be careful that this one here refers to triangle ABC. So a triangle symbol and then 3 letters basically directs you to the triangle in which we are working on. So I need you to be aware of this, and I need you to take note then that given this, I could write my 3 ratios in different ways. If I look at point A as an angle, then I could say sine of angle A here, the opposite is what? Becomes this side with small a, and the hypotenuse will remain B, and the hypotenuse never changes. Okay, be aware of this. If I wanted the cosine of angle C, and I'm being quite deliberate here, it will be the adjacent, which is side A over B. And yes, indeed, you are right. There is that special relationship between sine and cosine. This is not an accident. As I said, I am quite deliberate here. You will see why later on. The tangent, if I use angle A, I will be looking at A as the opposite and C as the adjacent. Take note, the tangent of angle A is actually different from the tangent of angle C, because if you look at angle C, then it will be C over A. So take note of those little things. So go ahead and discover what will be the sine of angle C, what will be that ratio, and what will be the cosine of angle A. Go and find out what that is. Of course, I hope you do notice once you have sine of angle C, you basically have cos of angle A. We do not bother ourselves that much about the angle, the cos or the sine or the tangent of 90 degrees, because that's a special angle. More on that later in this series. Okay, a few things I need you to also note that the theorem of Pythagoras is still very much applicable here. So don't throw that away or do not forget about it. Remember, in this case, we could write it and say a squared plus b squared is equal to c squared. Or we could use the capital letters, and instead of saying instead of saying a squared, you see, I would say b squared here, there. And then instead of saying b, yeah, I did think I made a mistake here. Well done if you picked that. I wanted to say my bad so much, but I was not sure actually what I was referring to. My apologies there. So watch this. We want to say a squared plus c squared is equal to b squared. That is now correct. And we also now want to write this in terms of capital letters, and it will be bc squared plus ab squared, and that is actually ac squared. All right, so please be aware of this. This is just courtesy to say you don't want to lose marks unnecessarily. I'm sure you will really want to hit yourself there for losing marks when you could have avoided this. So be aware of that. I'll take you through one of the first examples in the next video. Thanks for tuning in.